Inventions, and Technology.
This engine drives the generator, which feeds the electric motor and thus the drive shaft. But in contrast to conventional trucks, the e-highway vehicles also allow for purely electrical operation. To connect the system, a sensor checks whether the traffic lane is equipped with a contact line. The truck then automatically raises its pantograph, or the driver manually initiates the process. The pantograph actively positions itself to the overhead contact line, which is continuously supplied with electric energy by the substations. When connected, the pantograph transfers this energy directly to the electric motor. Simultaneously, it can charge the battery. Sensors and actuators ensure that the pantograph remains connected and that wear is minimized. During braking, electricity is generated as the flow of energy is reversed. This electricity can charge the battery on the e-highway truck, power other vehicles connected to the system, or be fed back into the network. The pantograph allows for flexible operation of the truck in all traffic situations. The e-highway trucks are just as versatile as conventional trucks, and with the onboard battery, zero-emission transport becomes possible along the entire transport route. When overtaking another vehicle or at the end of an electrified section, the pantograph lowers itself into a safe position. Thanks to the hybrid configuration of the e-highway truck, uninterrupted transmission of power is guaranteed. Existing roads can be upgraded with the e-highway infrastructure. When equipped, the roads remain fully accessible to all other road users. The high energy efficiency of the system leads to reduced operating costs and thus economical transport. The electrification of trucks minimizes local emissions and has the potential of significantly reducing CO2. The e-highway system combines the advantages of electrified railways with the flexibility of truck transport.